Hey everyone, Mr. Voikin here, and lesson 2 of Unit 7. We're going to be looking at expanding upon what we're going to need to know about relations and functions. So basically what a relation or function is, it's looking at and trying to understand the relationship between two quantities. And quantities are just sort of things. So such as in this example below, the function is represented in words. So it says the cost C, cents per kilometer, is of driving a car is related to the speed S in kilometers per hour at which the car is driven. So in this case, the uppercase C is the variable that represents cost, and the units will be cents per kilometer. And the lowercase s is the variable that represents speed, and the units for that will be kilometers per hour. Now, we got to get used to the different language that is going to be used. So when you're asked to answer questions, we may have to understand what is the dependent variable and what is the independent variable. So you can see up there in pink it says that cost depends on how fast the car is being driven. So cost depends on speed. So cost is the dependent variable and speed is the independent variable. Other terms that represent the dependent variable are going to be the values on the y-axis, the range, and the output. So these are all falling under this one right here, which is the dependent variable. The independent variable, which is right here, can be also presented as the values on the x-axis, the domain, and the input. Okay, now let's take a look at other ways that we're going to see this throughout the unit. So we're going to see this quite often in a table of values. And as a table of values, the input, remember, is the x, and the output is the y. And the input will always be on the left, and the output will always be on the right. Remember that the input is our independent variable, and the y is our dependent variable. We can also just present them as ordered pairs, and again this would be our x and that one would be our y. So just like the table of values, x is on the left and y is on the right. Now we will also see a table of values written out this direction here, in which case the x would be on top and the y would be on the bottom. So we would have 20 and 10, 30 and 9.1, 40 and 8.4, etc. Okay, so it could be a table of values that is sort of laid out vertically or horizontally. Okay, you may also see this mapped diagram or be asked to create a mapped diagram. This is supposed to be a G, not a D, mapping. So this is a mapping diagram. Okay, and again, the x values are on the left and the y values are on the right. Okay, and finally, we're going to, well, not finally, there's two more. The graph is right here, and don't forget, and you should know this, x is going to be on the bottom, and y is going to be the one that is vertical. So x is your horizontal axis, and y is going to be your vertical axis. And then these points right here are going to be referencing sort of these values down here and over, and over here. So basically that point right there, we can see on the X is 40 and on the Y is 8.4. And if I sort of follow this one, the 40, it's going to follow this arrow over to the 8.4. And on here, when I have 40, it's represented by 8.4. And right here, 40 is represented by 8.4. So these are all visual. And finally, we get down to what we have as an equation. So in this case, the cost, which is, again, our Y, is equal to 0.001 times S squared minus 0.14S plus 12.4. And remember, these would be the X values. Okay, so make sure that you are familiar with all these sort of visual representations, and this part right here is going to be very important, that you can identify dependent and independent Y and X range, domain, output, and input. Okay, so let's take a look at the class example 2. So it says, take a look at these different visual representations, and in example I, it says state the independent variable. Now remember, the independent variable was our X. So we look back here, the independent variable right here is our X values. So, and remember from all these diagrams we were looking at, the X was always sort of on the left. So that's X, that's our X, and this would be our X right there. Okay, so the independent variables are going to be P, V, and in this case, the B. II states, well, what are the dependent variables? Remember, that is the Y, and our Y is on the right side of all this. So that is going to be, in this case, the Q, the A, and the C. Okay, III says, what are all the inputs? Well, remember again from up above, the inputs are right here, that is the X, and the output is the Y. So again, all I have to do is to state the inputs. I'm just going to take a look at, well, that's going to be what's coming in on the X, which is 5, 8, and 11, 4, 10, 25, and over here it would be 3, 4, 5, and 6. And then our outputs would be the Y values, which are 10 and 6, 14, 12, and 15, and 7, 11, 15, and 19. Okay, and class example 3 says we got some diagrams and again an equation right here, and it's again asking us to state the independent variable. So these are just terms that you got to become familiar with and be able to answer the questions as they're presented to you on tests. So independent, we got to think about well, what is the independent? It is the X, and the dependent is the Y. So in this case, the Y is always going to be right here, equals the X sort of is going to be over on this side. Now notice that we've got this variable which is pi, and that even though that's a variable, it's a constant that represents 3.14. So what is our independent variable in example A? Well, that would be the R for radius. And what is the dependent variable? Well, that is going to be the C in this case for circumference. And if we look at example B, what is the independent variable? Well, because this is the x-axis down here, the independent variable is going to be the time, and which is represented by t, and the dependent variable is going to be height, which is represented by h. So this is our y-axis and our x-axis. And now we want to look at this representation using words. The amount of sap, S, is dependent on the time. Now, anytime we see time, it is always the independent variable. Time does not stop, so it's not dependent on anything. So where is our independent variable? That's going to be time, which is t. And where is our dependent variable? That's the amount of sap, which is S. Okay, with class example 4, we're going to be asked to do a number of different things. So let's just get started here. It says we have this equation, which is y equals 2x minus 5. And you should be able to realize that that is in the form of y equals mx plus b. So that's going to be the equation for a straight line. Now remember, m is our slope, b is our y-intercept, x is our independent variable, and y is our dependent variable. So on the left here in example A, it gives us a table of values. And right down here in the left column are our x values, which are the input values. And all I need to do is take these values right here, these x values, and put them into this equation. So substitute -2 into the x. So I highly recommend to sort of take your variable and replace it by 2 brackets, and then put that variable inside. So in this case, it's going to be y equals 2 times -2, which is -4 minus 5, and -4 minus 5 is -9. So when we have an input of -2, our output should be -9, giving us the ordered pairs of -2, -9. Now I just continue to do that for every one of these input values. So for the second one, y equals, again, it's 2 times whatever the input is minus 5. In this case, it's going to be -1. And I have -2 minus 5, which is -7. So this is going to be a -7, giving us the ordered pairs of -1 and -7. So I'll just quickly take these. Whoa, what happened to my other information there? Okay, let me do that again. Take that. That's not allowing me to shrink it down, so we'll just do something different here. Okay, so now I want to take a look at this one right here, which is 0. So when I replace x with 0, it's just going to make this 2x right here equal to 0. So basically, I can see that it's going to be -5 right off the bat. So when it's 0 on an input, my output is -5, and the ordered pairs are 0 and -5. Now you should sort of see a pattern on the output here. It's going from -9 to -7 to -5. So in each time we move to the next input, we're increasing by 2. And as long as the input is consistent, then the output will also be consistent. So -2 to -1 is going to be +1. And again, +1, and again, +1, and again, +1. Okay, so I should be able to fill these ones down here as a 3 and a 4, and this should just increase by +2 each time, +2 and +2, etc. So it would go to -3, -1, 1, and we should have 3. So just to test that theory out, let's take a look at this one down here where we said that x was 4 and we had an output of 3. So I'm going to have to write small over here on the side. So I'm going to have y equals 2 times whatever it is there. My input minus the 5. The input is going to be 4. So y equals 8 minus 5. So y equals 3. Everything looks good there. Okay, so I can finish this out by writing my ordered pairs. 1, -3, 2 and -1, 3 and 1, and 4 and 3. Okay, now it's asking us to plot these values on the Cartesian coordinate system to the right here. So I'll start off with -2. So we want to take a look at where the x and y axes are. So here is our x going this way, and the y is going up and down. So I want to start off in the x direction, go -2 and -9, and that is going to put me right here. And the next one is -1 and -7, followed by 0 and -5, and 1 and -3, 2 and -1, 3 and 1, and 4 and 3. Okay, and you should be able to see that that is forming a straight line that goes through all those points. Now it says connect the points on the grid and extend the line in both directions with arrows. So why are they asking us to do that? Well, because it basically means that this is a line that goes through all those points, and it will continue to go in both directions forever and ever, as long as there are no constraints on any of the input and output values. Okay, use the graph to determine the value of y when x is 6. So I'm just going to draw that line again really quickly, just so we can. So it should be sort of like that. And now if I want to determine what is the value of y when x is 6, I just want to take the x at the 6 point and run that straight up to the green line, and then grab it from that point and go over to the side and hit the y-axis, and you can see I'm hitting that at a 7. So when x is equal to 6 down here, then y is equal to 7, and that point should fall on that line again. So when x is 6, y would be 7. Okay. Part E, use the equation to determine the value of y when x is 6, just to verify our answer. So again, we want to take our original equation, which was y equals 2 times x minus 5. We want to substitute the x with a 6, and I end up with y equals 12 minus 5, and in this case y equals 7. So verified using the graph and verified using the original equation. Write the value of y when x equals 6 in the table of values using the first blank space in A. Oops, well, I guess I filled that in already. So basically, if we were doing that, let's pretend we can continue down here. So it'd be 6, 7 with the ordered pairs of 6 and 7. Use the graph to determine the value of x when y equals 3. Well, same thing. What I want to do is I want to find y is 3. Is that what it's saying? When y is 3, and I want to draw a line straight across until I hit that line and then come down at that point to, well, it doesn't really line up there, but it would line up right there. So basically when y is 3, the x lines up with 4. And we can see that that is true on this line right here up in the table of values. Okay, and where are we now? We would be on H. Complete the following statement. This relation is called a blank relation because the graph of the relation is a straight line, and we call that a linear relation. Now, if you look up on to the right of the screen, I've got the Calc 84 app opened up here, which simulates the TI-84 closely, not perfectly, but I'm just going to go through sort of some of this stuff that we did right here to see how we could use the calculator to sort of speed up the process right here. So first of all, we want to input this function, the equation right here. So I go to this y equals button, and I would just type in 2 and hit x minus 5. Okay, at that point, you can see that we've got the x values going down to -10 and going up to +10. The y values going from -10 up to +10. So that would be set right here in this next button, which is called the window. So you can see I've got it set to -10, 10 on the x min and max, and -10, 10 on the y min and max with a scale of 1, which means it's the x and y axes will be the same. Okay, now I can just hit the graph, and you can see there's that line that's being drawn on our application is the same that we drew once we plotted all those points. Okay, and I'm just going to close that out. Now, what about the table of values? Well, you can see above the graph right here, it says table. So it's written in green or yellow. So I think it's green. So if I hit second and graph, it brings up this table. So you can see right here at 0, on the x, which is the input, it gives us -5, which is going to be the same that we had here on our graph on that line. And now you can see this one goes all the way down. Remember that we were asked to input 6 and we got an output of 7, and that's confirmed here with the calculator. But there are no negative numbers, so I can go down and get some positive numbers, but there are no negative numbers. But that can all be set up in some of the menus within the calculator itself. So above window, you can see it says table set. So if I go second here and it says started at 0, well, let's just start that at say -5. Okay, and now I can go to the graph, which isn't going to change anything. But I can go to the table, and you can see that now we're starting off at -5. And if we compare that to our table of values in our exercise we're doing, when x was -2, y was -9, and you can see right here a value of -2 gives us a value of -9. So of course, it can all be done by hand, but the graphing calculator is a tool that sort of expedites this process. But it's going to be very important that you sort of know how to use all the functions on the calculator. Otherwise, it's just basically going to be good for multiplying, dividing, adding, and subtracting. So you need to practice using these different buttons and functions, and make sure that you can use them, because when we're doing the test, you can't be asking how to set things up or where to find things. That's your job to be prepared when you arrive at the test. Okay, and I'm just going to go back here to the table set right here. You can see this one says auto. There's also another one that says ask. So if I now go to the table, so second graph, it's now got a thing here saying, well, what value do you want to put in here? And I think I can just put in like an 8. So if x equals 8, I hit enter, and it just tells me that y equals 11. So what other value do you want? So if on the test I said to you, what is the value of y when x equals, say, -23, you would just type in -23, hit enter, and it tells you y would be -51. And again, what about when x is 125? Well, then y is 245. So as you can see, quite a powerful tool. Definitely useful in class. Okay, so class example 5 is the last one, and you can see that the equation that we're dealing with right here is slightly different in the sense that it's got that squared there. So as soon as we see that square, it's y equals x squared minus 6 instead of the last example, which was like 2x minus 5 or something like that. As soon as we see that the x value has an exponent of 2, then this is going to be what we call a non-linear equation. So again, to complete the table of values to the right, we have our inputs, and we just need to calculate our outputs, and that can be done by substitution, as in the last one, where we're going to go y equals, again, brackets squared minus 6. I'll take the first one, which is 4, replace that in there, and we'll also work the second one, which is going to, I'll do the last one, which is -3. So when I finish the one on the left here, I get y equals 4 squared, which is 16 minus 6. So I get y equals 10, giving us the ordered pairs of 4 and 10. And the other one, y equals -3 squared, which is -3 times -3, which is going to be 9 minus 6. So we get y equals 3. Now, if we take a look at the calculator right here, and I was to put in -3 squared, notice that we get -9 right there. So that's one of the reasons that I'm encouraging you to put these brackets around that, because that's going to allow you to not make a simple mistake when you're inputting this into the calculator. So -3 squared is different than if you put a bracket -3 squared. So you can see that one comes out to +9. So in the top one, it's saying square 3 and then make it negative, and the second one is saying square whatever's inside the bracket, which is -3 times -3. Okay, and so this one down here is saying that when I have a value of -3, then it's going to be a +3, giving us the ordered pair of -3, 3. Okay, now just as we did before with the last one, we can go on to our calculator right here, and we can say the equation is going to be x squared and then -6. So -6, and if I hit graph, you can see that we get the shape of a parabola. Now, what values do we have? We've got the values from +4 to -3, so I'll close this out. I'm going to go to second function and go to the table set, and we're going to be starting at, in this case, I will start it at -3. And it'll go up from there. I'll go on to auto. I will go back to second function graph, which calls up the table. And you can see that I get -3, 3, -2 and -2, -1 and -5, 0 and -6, 1 and -5, 2 and -2, 3 and 3. And if I go down here, I could probably fill this one in at 4 and 10. So notice that there, you should be able to see that relation right there. So now I just need to plot these points on the graph. So we're starting off with 4 and 10, going down to 3 and 3 and 2 and -2, 1 and -5, 0 and -6, and then it's just sort of mirrored on the other side here. So 1, 2, 3 over, and 1, 2, 3, 4 over right there, giving us this sort of parabola shape right here. And just like we did with the linear equation, we put those arrows there to express that it's going up and to the left forever and up and to the right forever. Okay, yeah, this is a -4 right there. So we just did B, we did C, we jumped ahead and did that. Use the equation to determine the value of y when x is -4, just to verify it. So again, if I look at my equation, which is y equals bracket squared -6, it's a -4. -4 times -4 is 16 minus 6, which equals 10. Verified. Awesome. Done. We did this one. Connect the points with a smooth curve. That was smooth enough. And like we said, this is a non-linear relation. Okay, that's it for that. So we've basically got this assignment right here to work on in class, which is going to be on page 406. And it's just going to be going over what I covered in the lesson. See you in class.